Okay, hi everybody. In this lesson here, we are going to take a look at one of my favorite things in mathematics, and that is the coordinate plane. Okay, the coordinate plane is amazing because it has allowed mathematicians, or everybody really, to visualize relationships in a way that we really couldn't have before that. Okay, so it's the coordinate or the Cartesian plane. It's named the Cartesian plane after a guy named Rene Descartes, okay, who was a philosopher, and he's the one that came up with the idea of the coordinate plane here. And the story goes that one day he was lying in bed, kind of reluctant to get up and face the day, and he was watching a fly crawl across his ceiling, and he had the thought, I wonder if we could like map out where the fly has been, where it's going to go here, kind of keep track, keep record of where it's been. And that is the idea that gave kind of birth to this idea of the coordinate plane, this two-dimensional plane where we are able to keep track of where an object is by identifying its coordinates. So it's made up of two intersecting lines, okay, that meet at right angles to each other, okay, and we call these the axes. Okay, here's an axis and here's an axis. Now, some more information about this. The horizontal axis is called the x-axis. Now, along the x-axis is where we keep track of, well, okay, let me put it to you like this. The one of the beautiful things about the Cartesian plane or the coordinate plane is that every time you put a point on there, that point, okay, is with respect to two numbers here. So that point can reveal a relationship between two different things here. There's a number along the horizontal axis, and there's a number along the vertical axis. Now, we go a little bit further into that. On the horizontal axis is where we keep what we call the values. This is the x-axis, and so on the x-axis here is the values of the independent variable. Now, that maybe doesn't mean much to you right now. In fact, you may have not heard that expression, independent variable, used. But if you've had a science class, you've probably used the term manipulated variable. Whoops. Yeah, manipulated variable. And it's the same thing. Okay, it's the same thing. Just in mathematics, we give it a slightly different term. We call it the independent variable. And then on the vertical axis, okay, we keep the values of the dependent variable. The dependent variable. Or from a science class, you might call it the responding variable. So the way you want you to think about it here is that you're the one who kind of controls. You're choosing what the value is of the x coordinate. Basically, you get to choose where you stand along the x-axis, and what you're interested in is what happens vertically. How far up do you got to go? You know, if I'm standing over here, where is that point? Where is that dot that indicates the value of that responding variable? Oh, it's such a powerful little tool here to show relationships here. The point 0, 0, where the axes meet, is the origin, okay? Because what happens here is basically the coordinate plane grows in all four directions out from there, okay? It grows in the positive x direction, positive y direction, and then the negative x direction, and then the negative y direction. Each point on the coordinate plane is described by a pair of coordinates, and this is what we've been kind of alluding to. There is a value of the independent or manipulated variable, so that's the thing that we choose. We're choosing what that value is, and then we're taking a look to see, oh, that's what the responding variable is. That's what the dependent variable is. So we choose this, and then we're very curious as to what the value is as a result of the y coordinate, okay? And now it's really important to know this, okay? You must use parentheses here, okay? If you don't use parentheses, like if you just put the numbers 2, 3 down, that doesn't mean anything. That's just a list of numbers. That's a 2 and then a 3. It doesn't become a pair of coordinates until you put parentheses around it. Okay, that's really, really important. The parentheses turn this into what you call an ordered pair. Okay, and the word ordered is because the first one is X, the second one is Y. Okay, now the first one is X, the second one is Y here. The reason why the first one is X and the second is Y is because it's alphabetic. Okay, it's in alphabetical order. Now, X comes first because it's easiest for us, quite honestly, it's easiest for us to go left and right, to process left and right. And then we look at vertical as the result of that. Okay, we look up and down as a result. So you're always glancing left and right first. We're always looking at the X coordinate first, and then we're looking up and down for the Y coordinate. And that's just kind of the way we do that. Now, each point lies in a specific quadrant. Now, for the most part, we'll talk about that in a second here, because the axes divide up the plane into 4 quadrants, and the quadrants are numbered 1, 2, 3, 4. And the reason why we start here, okay, in number 1, often the top right corner, is because in quadrant 1, both X and Y have positive values. Okay, and we're giving precedence to that quadrant because of that. And then we go around counterclockwise. So each point is going to lie in one of those quadrants, 1, 2, 3, or 4, okay, dot, 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 unless it is dot, 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 an intercept of some sort. Okay, so an x-intercept, that we give this term to a point where the y coordinate is 0. In other words, it's on the x-axis. So if you've got your coordinate plane here, all of your x-intercepts are going to show up somewhere along the x-axis on this line where the y coordinate is 0. They are in between the top of the top of the plane and the bottom of the plane. Okay, they're on that boundary between the top and the bottom. A y-intercept, on the other hand, is where the x-coordinate is 0, and that's going to amount to this. And this is on the boundary between the left side of the plane and the right side of the plane. Okay, so really the key point here to remember here is an x-intercept. At an x-intercept, the y-coordinate is 0. At the y-intercept, the x-coordinate is 0. Okay. Now, I suspect a lot of this information you've seen before in the past, because I believe this gets introduced earlier in your education here. This is really just to summarize here, because we're going to do some neat things with these ideas in this particular chapter here. But let's take a few moments here and answer some questions, again, just to get you back into the swing of how all of this stuff works. Okay, so in this little bit right here, what we're being asked to do here is to plot these points. Now we're going to identify what quadrants they're in as well here. But here we go. We're going to start plotting the points here. So A is the point 2, 3. So everything always starts at the origin. So from the origin, I look at the first coordinate right here, 2. So I'm going to go that's positive 2. So I'm going to go in the positive x direction 2 units. So that's going to put me over here. And then I look at 3, and it's positive 3. So then I'm going to go in the positive y direction 3 units. So 1, 2, 3. That puts A right here. And A is in quadrant 1. Okay, then I look at B. And the very first thing I bump into with B here is that -7. So again, I start on the origin, and -7, meaning I'm going to go -7 units in the x direction. Okay, so -1, 2, 3, 4, 5, 6, 7 out to here. And then +5, that's in the positive y direction, 5 units. So 1, 2, 3, 4, 5. So right here, this is point B. And notice that this is in quadrant 2. Okay, now question point C, -2, 9. So again, I start on the origin, and I'm going to move 2 units in the negative x direction. So that's going to be 1, 2 to right here. And then I'm going to move 9 units in the negative y direction. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're way down here. So here's point C right there. And this is in quadrant 3. And at this point here, you can probably guess where where the last point is here. But for D, again, the first coordinate is 5, and it's positive 5. So I'm going to move 5 units in the positive x direction. So 1, 2, 3, 4, 5. And then negative 1 is 1 unit in the negative x direction right here. So there's D, and that's in quadrant 4. Okay? Now let's take a look at a slightly different sort of a question here. So this question here is asking us, now if you look below it here and you can't quite see it, I'll just put this off to the side here. We are looking to label or to identify the x-axis off of this, the y-axis, the origin, and then we want you to identify which of these is the x-coordinate and which is the y-coordinate. Whoops. Okay. So we're going to just move that up a little bit here. And here we go. So looking around here, if I look at the point that I've been given, notice that this first box here, right here, is pointed at the 4. Well, that is going to be the x coordinate of that point. Because remember, in the coordinate, the set of coordinates here, the ordered pair, x comes first. It's alphabetic, x comes first, and that's the horizontal variable comes first before the vertical variable, which means this is then, this next one here, okay, this is now going to be the y coordinate. Now looking around, if I look at this box right here, it's pointed at the center, and we call that the origin. And then down here, these two boxes here are both pointing at the axes. This first one that it's pointing to is the x-axis, and this vertical one here is the y-axis. Okay, and there we go. Now, there are some questions below this that are going to ask us to come back and look back at what's going on up here. The first question says, label the diagram using the terms given above. Well, we've just done that. So this next one here says circle and write on the diagram where the x-intercept is located. Okay, where the x-intercept is located. Now, what they're referring to is the line. Okay, so let's highlight that line. They're talking about this line right here. So I'm drawing some sort of relationship here between x and y. It's this line that's being formed here. And so they want me to identify the x-intercept. Well, the x-intercept is going to be that point where it's on the boundary between the top and the bottom of the graph here. Because remember, points are either in the quadrants, okay, they're either in the quadrants or they're on the axis, or the axes, I should say. So when I ask you for the x-intercept, I'm asking you for the point that's on the x-axis here. So this right here, everybody, is our x-intercept. Now, I would be shocked if the next question wasn't asking, and there it is, where the y-intercept is located. And so that one there is going to be the point on that line. It's always going to be on that line here, okay? That's in between the left side and the right side of the graph here. And that's going to be on the y-axis. That's this point right here. So this point right here is the y-intercept. Okay, so we've got the coordinate plane, and we're going to throw a bunch of points on there. Remember, that line that we're seeing there that's highlighted, that represents an infinite number of points. We're looking for the very specific points on there that lie in between the quadrants there on the axes. And then this last one here, in which quadrant is the point -4, -1 on the line located in? So -4, -1, if we look up on this line here, -4, -1 is on that line. Okay, I start at the origin and I go over 4 units to the left on the x and then 1 unit down. There it is. So here's this point, -4, -1. It is on that line. And what quadrant is that in? Sorry, that is in quadrant, whoops, that is in quadrant 3. Okay, and in quadrant 3, what's unique about quadrant 3 is the x values and the y values are both negative. Okay, that looks terrible. I'm going to redo that. But that is one of the defining features of that quadrant, that the x and the y coordinates are both negative. Okay, now let's take a look at a couple of more questions here. So it says graph the equation of each of the following using the given grid. Okay, so we've got this y equals 2x, and then y is equal to x plus 1. We're going to graph them both on this line here. Let's try on this grid here. Now, to do this right now, we're going to start with a table of values. It's not going to take us very long, though, to kind of push past being using a table of values. We're going to give you some more powerful tools here in just a little bit here. But to start off with here, we're going to use the table of values. And so what I'm going to do is I'm going to choose some values for x, because remember how that works here. X is the independent variable. X is the independent variable. So I choose its values. And then we're looking for what the y values are. So what I might do here is I might choose a negative value for x, let's say -3. And then I choose 0 and then choose like a positive value. Let's say like +4. Okay. It doesn't really matter. I'm just giving myself just a handful of points here. So if I plug that in and I plug that in for x here, I put it into the equation here. 2 times x is going to be -6. 2 times -3 is -6. For this next point here, if x is 0, 2 times 0 is 0. And for this next point here, 2 times 4 is 8. So this is giving me a set of points here: -3, -6, 0, 0, and the point 4, 8. Okay, so on the graph here, -3, -6 would be starting from the origin, 3 to the left, and then 6 down. 1, 2, 3, 4, 5, 6. Ooh, right there. Okay, I might want to move that up just a tad. 0, 0 is the origin. And then the point 4, 8. So I go 4 in the positive direction on the x-axis. So 1, 2, 3, 4. And then up 8. 1, 2, 3, 4, 5, 6, 7, 8. And now what I might do here is simply connect those dots. Okay. Typically, you would see that I would put a little line, little arrows on there. This would be line 1. So let's label that. This will be line 1 here. And then I'll move on. The next one that we're looking at here is this function here, or this relationship here, x plus 1, y is x plus 1. Again, I'm going to pick just a handful of values for x. And let's say, I don't know, I choose -5. I choose 0 again. I like having 0 in there. And then I'll choose, I don't know, let's say 3. So here, -5 plus 1, when I plug in those values for x here, -5 plus 1 is -4. 0 plus 1 is 1. And then 3 plus 1 is 4. So this gives me these coordinates here: -5, -4, 0, 1, and then 3, 4. Now I'm just going to go to my grid and I'm going to plot those points. So -5, -4 is going to be -5 in the x direction. So 1, 2, 3, 4, 5. And then -4 in the y direction. 1, 2, 3, 4. So it's going to be right there. 0, 1 is going to be a y-intercept because the x is 0. And 0, 1 is going to be right there. And then 3, 4 is going to be 3 in the positive 3 in the x direction. So 1, 2, 3, and then up 4, 1, 2, 3, 4 right there. And then I might do the same thing. I might just connect those dots. Put little arrows at the end to indicate that this is going to go on longer than that. And this is going to be line 2. Okay. And so there we go. So we're seeing how these relationships here can be graphed. What we want to do kind of throughout high school mathematics here is we want to develop in you kind of an understanding or an instinct for what these things, these expressions, like what we're seeing here, for what they look like without having to go through the process of creating a table of values, where you'll have an idea just by looking at that equation what it looks like, because that will help you later on in kind of our ultimate goal, which is going to be solving equations. Okay, so the more comfortable you are with the way those things look, the easier it's going to be for you to understand what the solutions to the equations are that we're going to be working with later on. So I hope this helps. You probably take some time and work through some of those exercises there to make sure that you're approaching the coordinate plane correctly. Just big note here, just something to watch out for. A very common error. Okay, a very common error is moving vertically first. Okay, or basically people swap the coordinates here, okay? So swapping the x and the y coordinates. Really, really common error. So something to watch out for. Please make sure that you're being consistent. The x coordinate comes first and then the y coordinate.